Welcome, this is the next question. Okay, this is question number, almost said 3 then, I was going back in time. Yeah, so it's question number 6. Okay, we're asked to show that sine 3 theta is equal to 3 sine theta, take 4 sine cube theta, by using the idea that 3 theta is equal to 2 theta plus theta. Now they could have quite easily not told you that, and maybe at this level they probably well could have done. I mean, to be honest, I would have expected them to, especially in the hardest paper out of the trio. Okay, out of the 4 that are on there. Okay, this is definitely one that I would have expected them to not tell you that. Anyway, it's good they've told you. So the first thing that you would do therefore is obviously write this equation in with sorry, we're not, because to show that equation we don't write the whole equation out. We're just going to, obviously we want to show that sine 3 theta is equal to this. So we need to start with sine 3 theta and work towards that. But there's no point writing sine 3 theta, okay? We're already told 3 theta is equal to 2 theta plus theta, which is obvious, but it makes a hell of a difference when we work it out. Okay, so sine 2 theta plus theta. So we know our double our addition rule for sine. So if you're doing sine of a plus b, okay, that is equal to sine a cos b plus sine b cos b. Sorry, sine b cos a. Okay, to correspond that with this, you say therefore a is equal to 2 theta and b is equal to theta. Okay, so it's equal to sine a, so sine 2 theta, times cos b, or cos of theta, so times cos theta, plus sine b, so sine of theta, times cos of 2 theta. Now, it might be a good idea at this point to just drop in your double angle formula, because there's obviously, we've got to have it as all single angles, so we need to change these to single angles. So I would put somewhere as sort of a star, so you put sine 2 theta is equal to 2 sine theta cos theta. So as I was mentioning, we should know our double sine angle for or double identity for sine is sine 2 theta is equal to 2 sine theta cos theta. Okay, and obviously that is times by cos theta. Now I'm not going to clearly expand that just yet, because even though that's easy to do, we need to do this in stages. But obviously you can do that if you're feeling lazy. And then it's sine theta times cos 2 theta. Oh, sorry, I was continuing there. So that's sine 2 theta. Sorry, I do apologise. I lost my train of thought. But that's what you would do, okay? Cos 2 theta is the next double angle we need to state, okay, which is cos squared theta take sine squared theta. And then you actually do what I was doing there, is sub these two in now to the equation above, okay? And then always bearing in mind we want in equal to 3 sine theta take 4 sine cube theta. Okay, so continue this on. So sine 2 theta plus theta is equal to, well, it's 2 sine theta cos theta times cos theta. Okay, and we'll add sine theta times cos 2 theta. So sine theta times cos squared theta take sine squared theta. Okay, and the next line is obviously just expanding all of that. So sine 2 theta plus theta, or you can just write 3 theta here, it's totally up to you, huh? Okay, that obviously gets us 2 sine theta cos squared theta plus, we expand this bracket out, we get sine theta cos squared theta take sine cubed theta. Okay, now there's nothing, I guess you could put that as 3 sine theta cos squared theta. However, could you? sure if you could actually see what I've done. I do apologise. See if I've done that. So question 6. See what I've done. No, I haven't. Okay. So I won't, because I'll probably mess it up. Now you should know a very, very standard C2 identity of obviously sine squared theta plus cos squared theta equals 1, which obviously you can rearrange to get sine squared or cos squared theta, whichever is kind. Now why am I mentioning that? Well, in our answer here we've clearly got, for those of you that have got the benefit of sight, we've got cos squared theta and cos squared theta and okay. But in our answer, we've got just sine theta. Now I do apologise, I might have had a go at some people. I'm becoming Jeremy Clarkson, so do forgive me. Okay. Anyway, well that's such a bad thing at the end of the day. It's been money in the end. I might punch a few people, but as long as I get a bit of cash, that's alright. Anyway, so apart from that, I'm being fired by the BBC already. Anyway, so as I said, we just want sines in here. So what we're going to do here, the only equation I've got for cos squared theta is the rearrangement of this. Obviously we could put it as, cos 2 theta, but there's still enough with a cos 2 theta, and then we just want sine. Okay, so we rearrange this to get sine squared theta. Okay, so sine squared theta, sorry, it's cos squared theta is equal to 1 take sine squared theta. Okay, so we sub that equation into each cos squared theta. Now as I said, you might have combined that to be 3 sine theta cos squared theta, but said I didn't do that because obviously not as intelligent as myself. So 2 sine theta times 1 take sine squared theta plus sine theta times 1 take sine squared theta take sine cubed theta. Okay, now it's just a case of expanding this and simplifying it down. Okay, so if we to do that, it'd be sine 2 theta plus theta, or sine 3 theta, is equal to, well obviously this just expands to 2 sine theta take 2 sine cubed theta plus sine theta take sine cubed theta take sine cubed theta. Okay, so if you group them all together in terms of the sine cubed thetas and the sine thetas, okay, that obviously therefore gets you sine 3 theta or sine 2 theta plus theta is equal to what it says above, so 3 sine theta take 4 sine cubed theta, and you put a little thing at the side saying as required, so the examiner can't knock you off any marks at all. Okay, so that is your answer to question 6, part A. Okay, so that's only part A. It's quite a nice question, really. As I said, it looks a lot more difficult than it actually is. Okay. Now, part B. If you'd have just looked at part B without doing part A, as I said, probably should have been able to spot. Actually, should you? Maybe, yeah. As I said, maybe you could have done this actually without working out part A. As long as you use the answer, the show that part, okay, from part A, you should have been able to work it out. Okay, so what I'm just going to do now is just going to have a rub this useless bit of information off the board. Obviously, when I find a rubber. I do apologise. There we are. Okay, so one sec, sorry, is it not fixed the camera? Okay, so as I said, sorry if you just want to go back and copy that down, but as I said, it's just standard working out really. And this is the main bit we're interested in, show that bit. Okay, so bearing in mind this, the sine 3 theta is equal to 3 sine theta take 4 sine cubed theta. We need to use that idea to be able to work out the next part. Now, it's not as simple as some people might think, and it's probably more complicated than others might think as well. But it is question 6 on the hardest paper. Alright, anyway, so the question says it's solve for theta between 0 and pi and 3 for 8 sine cubed theta. Take 6 sine theta plus 1 is equal to 0. Okay, so we've got to solve that between 0 and pi and 3. Now, quite clearly, we can't factorise that, or we can't take out sines as a common factor. We can't solve it, essentially. We need to come up with some other method than trying to factorise it, okay? And what you would do, okay, well, you need to bear in mind it's not, obviously, we've not got a sine, because what we want to do, obviously, quite obvious, is giving us this straight off the bat without any guidance, okay, is a little bit mean. They've given us this part A to show that. They've not just randomly done it. It's weirdly enough related to the next part of the question. Okay, so we clearly know there's no sine 3 thetas in here. But is there any other part of this equation that we can relate to 8 sine cubed theta, take 6 sine theta plus 1? Well, there's a couple of things that we could do here. We could make 3 sine theta the subject, because we've got 6 sine theta here, and we could rearrange it and then double both sides. Double all of it. Or, easily, and what I'm going to do is rearrange this to get 4 sine cubed theta as the subject. Okay, and that's equal to 3 sine theta, take sine 3 theta. As I said, you should end up with the exact same answer, whichever way you do it. Okay, because we're going to end up with sine 3 theta sort of as a main part of this end bit. Okay, but we haven't got 4 sine cubed theta. We've got 8 sine cubed theta. Alright, and to get from 4 to 8, obviously you double it. So it's 2 times all of this, okay? So it's 2 times 3 sine theta, take sine 3 theta. Okay? So therefore, in this case of it's 6 sine theta, take 2 sine 3 theta. Okay? And that is equal to 8 sine cubed theta. Okay, so you sub that into this part of the equation. Alright, so let's do that. Okay, so it's 6 sine theta, take 2 sine 3 theta, take 6 sine theta plus 1, and that is equal to 0. Okay, so obviously the 6 sine thetas cancel. Okay, and then we're left with 1 take 2 sine 3 theta is equal to 0. So therefore rearrange this to get sine theta as the subject. Okay, so sine 3 theta, well, 2 sine 3 theta equals 1. So therefore sine 3 theta equals a half. The inverse sine both sides. So therefore we get 3 theta is equal to the sine inverse of a half. Okay. So if you were to do that on your calculators, you should get 3 theta equal to pi on 6. Okay? But it wants theta between the range of 0 and pi on 3. But we're dealing with 3 theta, not just theta. So we triple the range, okay? So 0 times 3 is obviously 0, and then pi on 3 times 3 is just pi. Okay, so that is a range for 3 theta. And then you've just got to remember, when you get your total answers, you divide all of your answers by 3, and it should remain in the original range of thetas between 0 and pi on 3. Now, I always use this method because I find it the easiest, and I always say that. I use the CAST method. Okay, some of you just remember the formula of what to add and what to take from each function, okay, it's a trig function, but our angle is pi on 6, okay, and it's where sine is positive, okay, all of them are positive, so it's there and there, okay, so top right quadrant, top left quadrant, okay, so CAST is, so C cosine is positive, all are positive, sine positive and tan. Okay, but quite clearly if it's positive, it's no matter what trig function it is, it's always in all, and then it's one of the other corresponding trig functions. Okay, so it's the angle here, which is pi on 6, and the angle there, which is pi on 6. Okay, so what we do now is we have a limit of between 0 and pi. So basically, we've only got two options here. There, and hit the other one. Okay, so 3 theta, if you're reading off this diagram, it's pi on 6, and then the next one is pi, take pi on 6, which is quite clearly 5 pi on 6. And to get theta, you divide both sides by, you divide all of it by 3, okay, so that becomes pi on 18 and 5 pi on 18, they don't cancel, so they are your end answers. Okay, and if you check, 5 pi on 18 is between 0 and pi on 3. Okay, so they are your end answers. Okay, just let me double check there's no other parts to question 6. Yep, that's the end of question 6. Oh, is it? Oh, great. No, it isn't. Great. Brilliant. We've still got a bit more to go, folks. Actually, this next part, I do apologise there. This next part, question 6, is a bit more irritating. Although, actually, in some respects it's not, because it tells you pretty much what to do. So, time for the to rub all this information off the board again. So if you're still with us, obviously you are, if you're listening, copy that down if you obviously want to. Okay, I'm just going to rub that off and move on to the next part. So this next question really is, again, going back to using the addition rule for sine. Okay, and the question says, using sine theta take alpha, okay, is equal to sine alpha, cos alpha, take cos alpha, sine alpha. So it's actually told us the formula here. So if you didn't know it originally, the addition formula, then you could just work it out because it tells you at the bottom of the page. It's quite nice. We're showing that sine 15 degrees is equal to a quarter brackets is equal to a quarter times root 6 take root 2, and obviously that'd be equal to obviously root 6 take root 2 all on 4. It's the same thing, obviously. We're asked to use the sine rule, but obviously we're going to be taking the angles away. Now, there are a couple of standard angles that you use for this. Okay, you've got obviously 15, but we can't use 15 because there's no addition rule. It's 15 plus 0, and that wouldn't get you anywhere, and clearly you don't want you to do that. You could use sine 30, so sine of 30 take 15, but then you would be working out the sine of 15 in one of your answers, okay, and that'd be worse, and that'd be pointless because that's what you're trying to prove, okay. So the only other alternative angles that we can use are 45 and 30. So in other words, it's the sine of 45 take 30, and if you correspond this with part B, where it says sine theta take alpha, theta is obviously 45 and alpha is 30. Okay, and it says that's equal to sine theta cos alpha. Okay, so it's sine 45 cos 30 take sine 30 cos 45. Okay, and you just sub in your values in your calculator. Obviously, that goes without saying that it needs to be in degrees. Your sine 45, your cos 30, and your cos 45 and your sine 30. Okay, and they should give you fractions. Okay, so it should be sine 45 should be root 2 on 2, and cos 30 should be root 3 on 2. Okay, and you take that away from sine 30, which is a half, times cos 45, which is root 2 on 2. Okay, now you could quite easily just remember you know, the little triangles of, you know, where it's let's see, the right angle triangles with these angles. But as I said, you've got a calculator, so you might as well just use it. As long as you break it down like this, they're never going to know. So it's a good way to cheat. Obviously, you wouldn't do that. And that is equal, therefore, to root 6 on 4 take root 2 on 4. Okay? And because it wants it, sine 15 is equal to a quarter of that, you just take out a quarter as a common factor. Okay, so it's a quarter, and then you just do root 6 take root 2, and obviously that is equal to sine 50, if you hadn't written that already, and that is as required. Okay, so really it's just a case of simplifying it down and working out an eventual answer. Okay, nothing too difficult, especially in the last question. It's more of a case of trying to understand what the question is asking and applying it to weirdly enough, the question you're given. But the actual maths, especially in that last part of the question, isn't too difficult. I don't think it is anyway. Okay, so thanks for watching. That is actually the end of question 6. I'll double check, it definitely is. But we've still got questions 7 and 8 to go in this paper. So hopefully you'll stick around for them too. And we'll see you in the next video. Question, or whatever you choose to watch next. If you do. Yeah, if you can stifle through another one.